Okay, today we're looking at Lesson 7. Your I Can statement or learning objective is I can graph and write quadratic equations or functions in Vertex form. So we spent the few weeks of the trimester before Christmas break factoring quadratic expressions. And now we're switching gears a little bit and we're looking at quadratic equations or functions. And those are different because we have an equal sign, and f of x equals our y equals. So we're changing from expressions to equations. And we have two different forms of quadratic equations or functions. We have vertex form and standard form. So today we're going to focus on vertex form. And as usual, I'm going to go through the notes and things quicker on the video than I would in person. So just know, be prepared for that. You can pause, rewind, watch it as you need to at your own pace. But I am going to be moving kind of quickly. I do expect you to be taking notes with me. There is a blank copy of some of the stuff you're going to see me use in Google Classroom. You're welcome to print that out and use it as we take notes. But if not, that's fine. You can just watch what I do and then apply that to Math Excel. The first little bit that we're going to write down is very, very important information, and I highly recommend that you write it down and have it to refer to while you work in Math Excel. It's going to make things easier because you're going to have to remember where to pull pieces of information from, and if you don't have that easily accessible, it's going to be more difficult. So I do recommend that you write this stuff down, okay? So we're going to get started talking about the vertex form. Okay, when talking about a quadratic equation or function, you need to know the most basic form of that equation or function, and we call that the parent function. So there are lots of different types of equations and functions, and if you want the most basic of that type, you call it the parent. So these are the parent quadratic functions. This is function notation, f of x equals x squared. This is equation notation, y equals x squared. These mean the same thing. X is our input, f of x and y are our output, okay? Those mean the same thing. You use it the same way, and you'll see me switch back and forth between the two. When you graph a parabola, or a quadratic equation or function, it is a parabola. It's a U shape, okay? It's a nice U-shaped graph. When we did absolute value, we had a V. These are U. And that point at the very, very bottom, or it could be the very, very top, is called the vertex. So we're going to talk about the vertex form. The vertex form of the quadratic equation or function lets you see the vertex really easily, and it helps you to graph. It's very, very helpful for graphing. And if you know the vertex form of a quadratic equation or function, you can apply the same rules to lots of other types of functions like linear, cubic, quartic, absolute value, all kinds of different ones. Okay, and it should look a little bit familiar to you. Okay, here is the vertex form, and I'm using y. I'm using the equation notation just because that's what you're used to. That's what you're used to seeing most of the time. So y equals a times the quantity x minus h squared plus k. That looks very similar to point slope form that we worked with back in the first trimester, and we really focus on point slope form. And at least I said that if you got used to point slope form, it would be helpful later on. And so this is when it's helpful because the vertex form is very similar to the point slope form. And if you look at your vertex form, you can find lots of different information from it. So first, you have h. So h tells you if you move right or left. So if this is a negative number, you move right, and if it's positive, you move left. Now, I know that seems opposite or odd, but that negative is part of our equation, so or our form. So you can't trust an x because that means the opposite of h. And you might remember, at least I said it back in the first trimester when we were talking about point slope, you can never trust an x. You just can't trust them. So it's always opposite of what it appears. Okay, so if it's a negative h, you move to the right. If it's a positive h, you move to the left. All right, the k tells you if you move up or down. Now, the k is straightforward. If it's positive, you're up. If it's negative, you're down. Okay? The other piece of information that you can pull from this form is a. And so we've got some different information to tell you about a. So first of all, if a is positive, that means your parabola opens up like this. It's a nice U shape. And this point, your vertex, is also your minimum, because that's the lowest point on the graph. All right, if your a is negative, your parabola is upside down. It's an upside down U, or like an N. And your vertex is also called your maximum. Now, when it's asking for the minimum or maximum point as an ordered pair, you're just going to tell the vertex, okay? But if it wants the minimum or maximum value, we're going to look at the other part. We're just going to look at one part of the vertex, and I'll show you what I mean in just a second, because everything's connected and everything works together, okay? Also, when you're talking about a, if you do the absolute value of a and it's less than 1, then your u is going to be fatter or flatter. And you can say either one. I refer to it as fatter, but it's also flatter. So whichever one you think there. All right. If your absolute value of a is greater than 1, then it's skinnier. Okay? And so that happens because a is kind of like the slope. If you have a fraction slope, like 1/2, that's going to go up slow or more gradual. If your slope is greater than 1, say it's 4, you're going to go up a lot quicker. So that makes it that skinnier U shape. Okay? And so an example of this would be like if a equals 1/3, and an example of this would be if a equals 5. Okay, so that's what I mean there. Next, we can talk about the vertex. The vertex is super important in the vertex form. It's part of the name. So your vertex is h, comma, k. So you take the h out of the form, you take the k out of the form, and you make your vertex. And so, like I said, it's that top or bottom point on your parabola, okay? The axis of symmetry is where if you have your parabola, you could fold it over the axis of symmetry and it would match on both sides. So you get that from h. So the axis of symmetry is just x equals h. And if you have a parabola, and this is the vertex, I'll use a different color here to show you. That is the axis of symmetry, okay, that dotted line, because you could fold the U over that line and the sides would match up. Okay. Sometimes you might be asked for the minimum or maximum value. And if you are, that's just K. Okay, it's that Y value, part of the vertex. Okay, next you need to know how to find the y-intercept, because some of your problems in Math Excel are going to ask you to use the vertex and an intercept to graph. And so the easiest intercept to find is just the y-intercept. So when you're looking for the y-intercept, that means x equals 0. So you plug it in and simplify. And I'll show you how to do that. But it would be good to make a note of it here, just so you know what to expect. Okay. Also, when we're looking at parabolas and quadratic functions, we need to know about the domain and the range. So the domain is our x. That's our input. And with a parabola, if you think about it on a coordinate plane, the ends are arrows. So they go on and on and on and on forever. So we don't know where the we don't know where it stops. We don't know how far right and how far left it goes. And you could plug in any value and get an output. So the domain is all real numbers, always. Okay, and you can see that a couple different ways. Sometimes you see a big capital R. Sometimes it's written out all real numbers. Sometimes it's an inequality. So negative infinity is less than x is less than positive infinity. But with Math Excel, some of your problems are going to ask you for interval notation. So that's parentheses, negative infinity, comma, infinity, close parentheses. And you can make a note that's interval notation. Okay. Okay, next we need to talk about the range, and it's a little bit different. So for the range, it's going to depend. If your parabola opens up and you have a minimum, then your range is going to be anything, so your y is going to be anything greater than that lowest point. So y is greater than or equal to k. Right? Sometimes in place of the y, it'll say all real numbers greater than or equal to k, but it means the same thing. For the range, it has to be greater than or equal to or less than or equal to some quantity. All right? In interval notation, it'll be bracket k, comma, infinity. Okay, because that means it starts here at k and then goes on and on forever. All right, if you have a maximum and your parabola opens down, it's going to be y is less than or equal to k. And your interval notation will be parentheses, negative infinity, comma, k with a bracket. And so, again, that's interval notation. And you will see that in Math Excel. So you need to make sure you write that down and know what it's wanting from you. Okay, so next we're going to look at the parent function. We're going to practice taking out these pieces of important information. We're going to look at what that parent function or that basic quadratic function looks like on the graph. I'm going to give you some tips for graphing, and we're just going to take a look at that before we work through some examples of your Math Excel work. Okay, and again, there is a blank copy of this in Google Classroom, so you're welcome to print this out and follow along with me. So, looking at f of x equals x squared, we're using that Vertex form, so a times the quantity x minus h squared plus k. Well, I don't see anything for h or k. There's nothing here. So remember, our vertex is h comma k. I don't see an h, I don't see a k, so my vertex is 0, 0. I'm going to go ahead and put that on the graph, 0, 0. Okay? The axis of symmetry is just x equals h. So x equals, my h is 0. Okay? So that means that this is my axis of symmetry. If I fold my parabola across that line, it's going to match on both sides. Okay? Now, the domain. The domain is always really easy. It's all real numbers. Or let's practice putting it in interval notation. Negative infinity, comma, infinity in parentheses. Now, the range is a little bit different. So we have to look for the A. So my A here is 1. Okay, so that means it's positive. So my parabola is going to look like this. And I have a minimum. So that means that my range is going to be bigger or equal to K, which is 0. And in interval notation, that would be 0, comma, infinity, with a bracket around 0 and parentheses around infinity. Okay? So we've pulled out all the important information, and I could graph it from here. Okay? But I'm going to show you how it works if you plug in values in a table. And then I'm going to show you a shortcut, a nice little trick. So if these are our x values and f of x is x squared, we plug each of these values in for x. So negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. What do you notice? As you cross from the negatives to the positives, you pass that vertex that we found, the numbers repeat. Okay, that's what gives us our symmetry. So it's going to be the same on both sides of the vertex. Okay, so we have negative 3, 9, and negative 2, 4, and negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Okay, you can use that to make your U shape. I'm going to try really hard to make it a good U shape. Sometimes I'm not very good at it. There we go. But the main thing is you need to make sure you have a nice rounded edge here at the bottom. It is not absolute value. Absolute value had those very sharp edges, very sharp point. This does not. This has that rounded edge. Okay, so this takes up a lot of time. And if your equation is kind of messy, there's lots of stuff, it's not as easy to find really good points to plug into a table. So there's a rule called 1A, 3A, 5A. And you can use that to graph any quadratic. After you find the vertex, you can use this rule and it'll help you graph. So you do 1 times your A. So my A is 1, so that's 1 times 1, 3 times 1, and 5 times 1. And that gives me 1, 3, 5. Okay, and I'm going to use a different color just to show you what I'm doing here. So if I use this, I can start at my vertex. And for 1, that means I go over 1, up 1. For 3, from that point, I go over 1, up 3. So over 1, up 1, over 1, up 3. And then 5. So over 1 and up 5. Okay, and that'll work every single time. If you have a different number for A, you just fill in a different number and you do the same thing. So you just do whatever number it says. And that can be a really handy, helpful way to graph. Now, some of your math Excel problems, you'll be able to do that on. Sometimes it asks for a specific second point. And I'll show you the difference as we work out some of those problems. Okay, so let's move on to the next one. So before we even start pulling out any information, let's look at it in comparison to the first one. So this one was just an x squared. This one we have a negative 3 inside and a 5 on the outside. So based on what I wrote down in those notes earlier, this tells me that my U shape is going to be moved right 3 and up 5. Okay, so it's going to look just like this one, except it's going to go over 3 and up 5. Okay, so we can pick out our A, our H, and our K. Our vertex is H comma K. So 3 comma 5. Our axis of symmetry is just X equals our H, so X equals 3. The domain, let's do interval notation, all real numbers. And the range, okay, so let's think about it. So our A is 1 again. That means it opens up. We have a minimum. So it's going to be Y is greater than or equal to 5. So in interval notation, that's 5 comma infinity. Okay? Or in Math Excel, it might say all real numbers greater than or equal to blank, and you would fill in a 5. Okay? Now, let's graph it. So my vertex is 3, 5. So 3, 5. And let's use our 1A, 3A, 5A. 1A, 3A, 5A. So our A is 1. So 1 times 1 is 1, 3 times 1 is 3, and 5 times 1 is 5. So from here, I'm going to go over 1, up 1, over 1, up 3, and then I ran out of room. Now, I don't have to do the other side because I know that the left is going to be the same as the right. So I'm just going to mirror or reflect those points to the other side. Now I can make my nice little U shape. And we said that this graph should look just like the first one, except moved over 3 and up 5. And it is. our last one, we're going to do the same thing, but we've got a different A this time. So you can label A, H, and K. So the vertex, our H, this time it's positive on the inside, so we have to do the opposite. You can't trust an X. So it's not a positive 4, it's a negative 4. And our K is -1. Our axis of symmetry is x equals -4. Our domain is all real numbers. And my range, okay, so this time it's negative, so we're going to go down, okay? So that means y is less than or equal to -1. Or in interval notation, and I already almost messed it up. I'm glad I caught myself before I kept drawing that. So in interval notation, so our biggest number is -1, and it goes to -infinity. So we do that -infinity with the half of the parentheses, and then -1 in that bracket. All right, so let's graph our vertex, -4, -1. All right, and let's do the 1A, 3A, 5A. So 1 times -2, 3 times -2, and 5 times -2. That's -2, -6, -10. So from my vertex, I'm going to go over 1, down 2, over 1, down 6, and looks like I'm out of room there. So I'm just going to reflect those on the other side and draw my nice U shape. And there we have it. Okay, so we're just doing that same thing every single time. Okay, so the rest of our notes or examples are going to be a little bit different. I printed out a preview of the Math Excel assignment that you're going to do, and I'm just going to walk through some of them just so you can see what it's asking you to do and what's expected of you, and there won't be any surprises there on your assignment. Okay, so if you want to open up Math Excel and work along with me, you can. But I think that there is a blank copy of this in Google Classroom as well, if you want to print it out and follow along with me. Okay, so we're not going to do all of them. I just picked out a few. On number 1, it wants you to find the vertex. And so that's easy. It's the opposite of what we see here. So -4 and 2. And that's it. You're just finding the vertex. Number 3, it says identify the vertex, axis of symmetry, minimum or maximum value, and the domain and the range of the function. So we're going to have to pull out a lot of stuff here, okay? So first, the vertex. The opposite of -6 is 6, and then our y is -24, okay? The axis of symmetry is just x equals our h, which is 6. The maximum or minimum value. So when it asks for the value, it just wants k, and it's -24, but you have to decide if it's a maximum or minimum. So our A is -1, so that means that it's going to open down, so it's going to be the maximum. So the maximum value is -24, okay? Then it wants the domain. The domain should be easy. It's always all real numbers. The range, though, again, a little bit different. And you notice it's set up different than how we wrote it, but I told you this could happen. So instead of y, it has all real numbers, okay? So let's think. So we said it has a maximum, so it's like this. All right, and we know our number is -24, but are we looking for values greater than or less than? It's going to be less than or equal to and -24. Okay, so again, that's a little bit different wording than what we did, but you're still doing the same thing. Here's number 4. So use the vertex and intercepts to sketch the graph, and then it wants you to find some other pieces of information. So first, let's graph it. So here's H and K, so our vertex, is -4, -9. I'm going to go ahead and put that on the graph. So -4, -9. Okay, and then it wants you to use an intercept. Okay, so we're going to find the y-intercept by plugging in 0 for x. So f of x equals 0 plus 4 squared minus 9, and that gives us 16 minus 9, and that is 7. So our y-intercept is 7. Okay, and that's all you need in Math Excel. If you plot the vertex and then the y-intercept, it'll make your U-shape for you. Now, I'm not as lucky here on my graph, so what I'm going to do is I'm just going to mirror it onto the other side of the vertex. So 1, 2, 3, 4. There we go. And we'll make our nice U shape. And again, on Math Excel, it'll make the nice U for you. And it'll look way better than mine. Okay, the axis of symmetry is just this line. You don't have to graph that, but it just wants you to tell it. It's x equals -4. The domain, and it says interval notation. It will tell you if it wants interval notation. That's -infinity to +infinity. The range, so we have a minimum, so we're going up, so it's going to be greater than, and I'm going to write it down here just so I can work off of it. So y is greater than or equal to -9. So in interval notation, that's going to be a bracket, -9 to +infinity. Okay, and you have another problem almost identical. It's going to ask you to do the same kind of things. It's going to ask you to use the y-intercept, so you'll have to plug 0 in for x, just like we did there. Okay, next, it says graph the function and describe how it was translated from the original. So this one, it should be super easy. It's our original, x squared. It just moved down 5. Okay, so instead of being at the origin, we're going to go down 5. And we can use our 1A, 3A, 5A. So over 1, up 1, over 1, up 3, over 1, up 5. Okay, and again, I think you only have to do 2 of those for Math Excel. You just have to do the vertex and you just have to do the vertex and one other point. But if you were graphing it by hand, you could do a couple more. And so we said that -5 on the outside means it's moved down 5. And so 5 units down. Okay. Number 7, we're going to do the same kind of thing. We are graphing that equation. So we're going to do the vertex. So I don't see an H or a K, so my vertex is 0, 0, just like before. And my A is -3. So I'm going to use that 1A, 3A, 5A. So 1 times -3 is -3. 3 times -3 is -9. 5 times -3 is -15. Okay? And again, in Math Excel, I think you only have to do one more point. So we're going to go over 1 and up 3, and then over 1 and up 9. Okay, and I can just mirror it on the other side. And you notice your y-axis is counting by 3s, so that's super, super helpful. It makes it really, really easy to graph. Okay, again, we're doing that same thing as before. Okay, number 8, we are filling in the table of values. So all you have to do is plug each of these numbers in for x. Okay, so negative of -2 squared minus 3. So that's -4 minus 3 is -7. And then negative of -1 squared minus 3 is -1 minus 3, which is -4. And then negative of 0 squared minus 3 is just -3. Negative of 1 squared minus 3, that's negative 1 minus 3 is negative 4. And then negative of 2 squared minus 3 is negative 4 minus 3 is negative 7. And you notice those repeat. We talked about that earlier. All right, and we can plot those points on the graph, or fill in your table first. So negative 7, negative 4, negative 3, negative 4, negative 7. Okay, so negative 2, negative 7, negative 1, negative 4, 0, negative 3, and then that we're going to mirror and make your nice little U shape. There you go. Okay, and we've just got 2 more. We're almost done. Write a quadratic function to model the graph to the right. So we have f of x, and our form is a times the quantity x minus h squared plus k. All right, so first let's find the vertex. It's right here at 3, 5. So we're going to plug a 3 in there and a 5 there. And then we just need to figure out our a. So we're going to use the 1, 3, 5 and see if it lines up. So over 1 up 1, that works. Over 1 up 3, that works. Over 1 and up 5, and that works. So our a is 1. So we're going to have the quantity x minus 3 squared plus 5. And that's our answer. Okay, and our last example, and you have a couple problems like this. I think you have one more, like number 9. I think it's actually number 12, though. And then you have 2 like this. So you really have 12 problems total. Okay, so you're given the vertex, which is h and k. You're given the point, which is x and y. So we're just going to plug that in to the form and solve for a. So y is negative 4. A, we don't know yet. X is 2. H is 1. K is 3. So now we're just going to simplify. So 2 minus 1 is 1. And then negative 4 equals a times 1 plus 3. We subtract 3 from both sides and get negative 7 equals a times 1, or 1a. And so that just gives us negative 7 equals a. So now we're going to take our a, our h, and our k and plug it in. So we have negative 7 times the quantity x minus 1 squared plus 3. And that's our final answer. Okay, so like I said before, use these examples to do your work in Math Excel. If you have any questions or need any help at all, I'm here. Rejoin the Google Meet, hit Ask My Instructor, send me an email, whatever you need to do. But I'm here to help you and happy to do so. All right, have a great rest of the day.